Okay, time to do a few more trig equations here. This time I'm going to focus on ones that are quadratic in nature. One thing that I think about when I'm doing quadratics, they got squares in it, that I'm probably going to get everything over on one side, 0 on the other, and factor it. Although in this case, and I notice it because there's no linear term. There's squareds, there's constants, but there's no just sine of x to the first power. It's easier in this case, I think, to solve it kind of like a linear equation and move the 1 over and then divide by 2. So I've got 2 sine squared x equals 1, and then divide by 2, I've got sine squared x equals a half. Right? Now, remember, the sine squared x literally means take the sine of x and square the result. So when I'm thinking about how do I get into the x here, x is buried inside of a sine, but the sine is buried inside of that squaring function. So to get out, I've got to do those in the reverse order. I've got to get rid of the squared first. So take the square root of both sides to get that the sine of x is either plus or minus the square root of 1 half, which would be just 1 plus or minus 1 over the square root of 2. So this really gives me two equations here, because it gives me that the sine of x is 1 over the square root of 2, or it gives me that the sine of x is minus 1 over the square root of 2. So I'm looking at each one of those individually. Sine of x equals 1 over the square root of 2. I'm thinking sine is 1 over square root of 2. Ooh, that's probably my 45-45 right triangle. It is. Right? Or I could have it here. So I'm looking at this equation. It looks like x is going to be pi over 4, or anything coterminal with that, so plus 2 pi n. Or it could be x is, what's that, 1 pi, 3 pi over 4, plus 2 pi n. Okay, so that's that one, but now I've got the sine is equal to minus 1 over the square root of 2, which would look this way, minus 1 over the square root of 2 in the fourth quadrant, or maybe minus 1 over the square root of 2 here in the third quadrant. So this is now, it looks like to here is 5 pi over 4, or anything coterminal, so plus 2 pi n. Right, the period of sine is 2 pi, so every time I add 2 pi onto this angle, I'm going to get something with the same sign. And what do we got here? Oh, or this one over there. So x is 7 pi over 4 plus 2 pi n. So if you gave me all four of these equations as an answer, it's like, okay, you've got them all. Some people might notice here that, you know what, we can actually say this a little easier, because the gap between here and here is pi over 2, and then the gap between here and there, which is this one, is pi over 2, and the gap between here and here, which is this one, is pi over 2, and from here to there it's pi over 2. And so actually we could just say x is pi over 4 plus pi over 2n. Right? That we can describe all of the answers in just this one formula, rather than having to give four different formulas. I don't really care which way you do it. I accept both of them, but I think it's good to point out that you could do either. All right, let's try another one here. Another one of quadratic nature. How about two? I seem to be stuck on sines here. Let's go with cosines. Let's just go with cosines. 2 cosine squared x minus the cosine x minus 3 is equal to 0. Okay. Now, this one does have a constant, a cosine just to the first power, and a cosine squared. So we really do need to treat this like a quadratic thing, if you can, a quadratic equation. We could use the quadratic formula, but I always find that if I can factor it, it's probably easier to do the factoring thing. So let's try it. This would be 2 cosine x times cosine x. I need a 3 and a 1 to do that 3. If if I put a 3 and a 1 here and make this one negative and make this one positive, then my outside terms are plus 2 cos x, and my inside gives me a minus 3 cos x. Plus 2 minus 3 is a grand total of negative 1 cos x, and then the minus 3 times plus 1 is the negative 3. So good. So that does factor, and that gives me two equations now because I've got it equal to 0 over here. So 2 cos x minus 3 equals 0, or cosine x plus 1 equals 0. This one tells me, it's like, how many steps do I need to do of algebra? Is it hard if I take the 3 over and divide by 2? Right, likewise here, if I take the negative 1, I'll take the 1 over, and, well, I guess that one's easy. So I look at that and say, when is the cosine equal to 3? When is the cosine equal to 3 halves? If I wasn't thinking, I might just kind of type that into my calculator, that x is the inverse cosine of 3 halves, but 3 halves is 1.5. Cosine is never as big as 1.5, right? So this is never, that there aren't any x's that satisfy this equation. So my only hope for solutions is if I get them over here. And cosine does equal minus 1 sometimes, so I'm looking at my cosine curve thinking, when does it get down to negative 1? Well, that would be halfway through its cycle. The cycle is from 0 to 2 pi, so this one must be pi and negative pi, and I guess that would be 3 pi right there. Right? So it looks like x equals pi plus 2 pi n. Okay, and that's the only places. Two things to point out on this one. Factor like you would a quadratic equation, or quadratic one, you know, and then set each factor equal to 0. The second thing to point out is that, you know, once in a while you're going to have parts of it that don't give you solutions. That's okay. Look at the other parts. It may be that both parts don't give you solutions, in which case there are no answers. Sometimes that's the case. You just say there aren't any values of x that satisfy this equation. Yeah. If that's the case, that's the case. One more that I want to do here. So which is that one? Yes, I want the cosine squared of x plus the sine of x to equal negative 2. Solve for x. Solve for x. Well, this one is a little different in that it's got both sines and cosines in it. It's going to be easier, I think. In general, it is. If you can get it down to just one trig function, that's a good thing. And if you can't get it one trig function, then maybe factoring to get just one trig function each factor. That's often a way to go. But here I do notice that cosine squared is differently related to sine. In fact, it's better related to sine squared. That I can convert that cosine squared x into a 1 minus sine squared x. And so what I have here now is an equation that's quadratic in sine x. It doesn't have anything else, just sines in it. So getting everything over to one side, I've got, if I add the 2 over here, I've got a 3 minus sine squared x plus sine x equals 0. And then I'm going to rewrite this. I'm going to multiply through by negative 1. So the minus sine squared is going to turn into a sine squared x. That's going to turn into a minus sine x. And the 3 is going to turn into a minus 3. And the 0, don't forget to multiply the 0. Sometimes people forget. You got to multiply both sides by negative 1. Anyway, so the 0 times negative 1 is still 0. And then factor this if you can. Maybe I can. Huh. And maybe I can't. I didn't write down the problem I thought I was going to, so I'm going to just take it as it is. Yeah, I don't think I can factor that because the 3 is going to be a 3 and a 1, and I'm not going to be able to combine them like that. So in that case, what I'm going to do is I'm going to use the quadratic formula. So, you know, I'm thinking of this like this. I've got y squared minus y minus 3 equals 0. So y is 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 3 all over 2 times 1, right? So I'm doing that, but instead of y's I have sine x's. So sine of x is equal to the opposite of negative 1 plus or minus the square root of 1 squared minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, which is 1. So I'm looking at the sine of x is 1 plus or minus the square root of, oh goodness, what is this? This is 13 over 2. So let me see here. I've got, I'm typing into my calculator here, 1 plus the square root of 13 divided by 2. Whoops, put it in parentheses. I didn't have my numerator all in parentheses. Oh, that's weird. So if I do 1 plus the square root of 13 over 2, that's equal to 2.30 something. And as soon as I saw the 2 point, it's like, oh, this is never going to happen. Right? No solutions out of that. So how about the sine of x equaling 1 minus the square root of 13 over 2? So now I'll try that again. In parentheses, 1 minus the square root of 13 divided by 2. And it says sine x equals negative 1.3, and that's never going to happen. So no solutions. That's what I get for not writing the problem down wrong. But well, that's all right too. We saw a couple things. One is sometimes you're going to use the Pythagorean theorem. If this gave us some numbers we could work with, then I would have taken an inverse sine at this point, but it didn't, and so I have no solutions on this one. Yeah, anyway, there's a few examples of the quadratic type.